In this video, we want to solve a question that is related to the frequency domain behavior of LTI systems. The problem statement says that we have an LTI system. It gives us the frequency response, which is h of j omega. It also gives us the output y of t, and it asks us to find the input x of t. To solve this problem, we need to know a few points, and first we will mention those points. The first point is that in the frequency domain, the output of an LTI system is equal to the input multiplied by the frequency response. So from this relationship, we can write the input in the frequency domain, meaning x of j omega, as y of j omega divided by h of j omega. Then, if we take the inverse Fourier transform of x of j omega, we will obtain xt. The second point is that the Fourier transform of e to the power of minus a2 ut is equal to 1 divided by a plus j omega. Now, by knowing these points, let's solve the problem. The first thing we need to do is to find yj omega. Based on the second point, the first part becomes 1 divided by 3 plus j omega, and the second part becomes 1 divided by 4 plus j omega. And then we subtract them from each other. After that, by taking a common denominator, the final result is obtained in the following form. Now, based on the first point, xj omega becomes yj omega divided by hj omega. So, if we substitute the values, we obtain for yj omega and hj omega and perform the division. In the end, we get xj omega equal to 1 divided by 4 plus j omega. Now the next part is to say that 1 divided by 4 plus j omega is the Fourier transform of which signal? That signal will be xt. And again, based on the second point, it corresponds to e to the power of minus 4t ut. In this way, the signal xt, which is the input of this LTI system, is obtained. If this video was useful for you, we have also posted other videos about solving signals and system problems on this channel, and you can watch them.